Hey everyone, I'm super excited to be here today with Chris and Anish to talk about model customization with fine-tuning with the Azure OpenAI service and weights and biases. I'm Alicia Frame, I'm the lead for fine-tuning on Azure, and we have Chris Van Pelt, the co-founder and CISO for weights and biases, and
Hey
Anish Shah.
everyone. Oh, I just wanted to say hello to everyone. Excited for today's webinar.
Anish, do you want to say
Same
hi?
here. Yeah, I want to say hello, everyone. Hope you're excited to learn some really cool information today. I'm excited to hear what to talk about.
And to show off your amazing demo. I think that's why people are really here, let's be honest. So just to kind of give everyone a heads up, if you have any questions while we're presenting, please put them in the chat. We will cover them at the end. And if there's anything kind of tactical, we'll try to get to it while we're presenting. But hopefully you guys are engaged, have a lot of questions for us, and you learn a lot today. So just to give a quick overview of what we're going to be talking about, we're going to start with some slides, sorry, just to level set on the topic. We're going to talk about what is fine-tuning, why folks might want to fine-tune, different industry use cases, and then how to fine-tune with Azure OpenAI and weights and biases. And then we'll get to the fun stuff, which is the demo. You'll see hands-on how fine-tuning can improve models and how weights and biases makes it much easier to create a high quality model. If we've got time, we'll close on agents and fine tuning, and of course have plenty of time for questions at the end. Chris, Anish, anything you want to call out?
No, this is a great overview. I'm looking forward to dive in.
Awesome. So one thing I always start these presentations with is what do I mean when I'm talking about fine tuning? Fine tuning is a super overloaded word. People will say fine tuning and they might mean prompt engineering. They might mean they thought about the project they were working on and made sure it made sense. When we're talking about fine tuning with Azure OpenAI and weights and biases, we're specifically talking about the process of customizing a pre-trained large language model with some kind of additional training on curated data for some kind of specific task or new domain, with the idea of creating a custom model that's just yours with your data that has better performance, new skills, or improved accuracy. Fine-tuning generally can refer to a whole bunch of different training techniques. You've probably heard things like RLHF, or reinforcement learning with human feedback, or you might have heard about supervised fine-tuning. These are all just different ways of adjusting a model for your use case, your data, what you're trying to get it to do. When we talk about what's available on Azure OpenAI, we currently support supervised fine-tuning, which I think is what you're going to see in the demo, as well as direct preference optimization, which is a technique to align your model to human preferences, as well as hot off the presses reinforcement fine-tuning, which can basically it's a way of teaching models how to reason about new domains. And these are just different techniques you can apply. I don't know, Chris, if you have any perspective on how you see folks frame fine-tuning.
Yeah, well, I think a thing that is lost on folks often when interacting with these like really impressive models is, you know, we sometimes think of them as like ourselves or like our own mind, that as we speak to the model, it is learning from what we're inputting. But in reality, the kind of state of the machine learning's mind is completely static. It's defined from the training process. And that state of its mind, it's actually the model's weights and biases, or its parameters. And this act of fine-tuning is actually going and changing that state and tweaking it so that the model can actually learn some new information more broadly, and then really be adapted to your specific domain. Now, I think that's especially difficult because in a way, these models do kind of learn when you're interacting with them through the context or through the actual data that's coming in. It essentially kind of reprograms what it might output based on information it's given, which is super powerful with use cases like RAG, which we'll touch on. But this fine tuning process is really it's much more aggressive than just tweaking the context within your application. It's really changing the overall preferences of the model and how it might handle different situations.
I think that's a great distinction. And if you think about it, like LLMs are essentially, next token predictors. Fine tuning is a way of just putting your finger on the scale of what should that next token be. So in general, you might have the most common word after the is thing, but when I've fine-tuned it, I've adjusted those weights. And so now in my use case, the most common word after the is cloud. And that's a really good way of kind of reminding folks, how do these models adapt? And when we talk about fine-tuning, there's really a pretty common toolbox, and we have these tools on Azure, also have these tools in weights and biases. Step 0 is figure out what you're doing. What is your use case? What's the scope? What are you trying to fine-tune the model to do? And once you figure that out, it can help you choose a base model. So let's say you want to fine-tune for, low latency, low cost, fast chat model. Well, then you're probably looking at something like 4.0 mini in the Azure OpenAI space. Maybe instead you're looking for a reasoning model. Then you might be looking for a 1 mini RFT or something like that, where you need to match the model to what you're trying to do. And then from there, you choose your fine-tuning technique. Are you trying to get the model to copy you, supervised fine-tuning? Are you trying to align the model's preferences with your own? That's DPO. Are you trying to teach the model to reason in new ways? Well, that's reinforcement fine-tuning. And from there, then it comes down to prepare your data set, train, evaluate, deploy, and monitor. And, that's not a unidirectional thing. Often you're going to prep your first data set, train, look at the model and be like, wow, this is terrible. And then try again and say, oh, I didn't cover these examples in my data set, or I really didn't have enough data, or it was too heterogeneous for the model to learn from. And so this is kind of a back and forth between training your model, seeing if it's doing what you're wanting. If it's good, you might put it in production, you might monitor it and then periodically update it. Otherwise, you might go back to the drawing board and say, I don't have the right data. Maybe I picked the wrong model. But I think this is another area where weights and biases really comes in and augments the toolbox.
Yeah, it's looking at this slide, it looks remarkably similar to the slide my co-founders and I used 7 years ago when we first started pitching potential investors the idea of weights and biases. I mean, this is truly the machine learning workflow, and it's the exact same workflow if you're training a model from scratch. So, the folks at OpenAI and really any other model provider has been iterating through this workflow to get us the various models that we have today. I will say, well, this looks fairly simple. I mean, there's a few steps here. This is a really tricky process to get right. And a few things I call out is, number one, the data set. That is really the model or the fine-tuned model. It's only going to be as good as the data set. So finding a really good data set, curating it, ensuring that it has a good distribution of examples. Like a failure mode with fine-tuning is if you have a data set that is heavily skewed towards one specific case, then your model is going to start to skew towards that specific case. And I'd say the other piece here that's deceptively difficult is evaluation. So figuring out how to measure the performance of the model, especially when you're doing these use cases that don't necessarily have a right or wrong answer, where it's squishy. Say you're summarizing something, or you're doing something where there's many correct answers, and you want to somehow pull out a sense of performance. It can be really tricky to get that right, but it is absolutely critical to do, because at the end of the day, you're going to be repeating this loop over and over and over again. By going down this path, there's going to be a new model that comes out in a month or two that you say, wow, I wonder if I could actually get better performance then, or your data set's going to change. There's going to be new information in the world that you need to kind of train the model on. So without that evaluation, you can't swap it out. Because if you got something in production that's working and you don't have a way to truly measure how this new version compares to it, you can't just swap it out and hope for the best. That is a recipe for disaster. So, I mean, this workflow is why weights and biases exists, and Anish is going to show you how we apply it in the platform later in the demo.
Honestly, the easiest thing about fine-tuning is the training itself and like running the fine-tuning job. 95% of your time is spent on the other boxes. And I think for people who are new to fine-tuning, they really get hung up on, like training is hard. I was a data scientist for a decade, training is hard. This really kind of turns that paradigm on its head. Training is easy. Making a good model is really hard. Super easy to make your model worse, challenging to make it better, but that's where you really see the value add. One thing, we've talked about what is the toolbox. One thing I've seen a lot of folks struggle with, and Chris mentioned this earlier, what is the GenAI journey? Where do I start? Sometimes people are like, I saw some LinkedIn influencer posts about fine-tuning. I'm going to do it. I've heard it's the hot new thing. And really your journey goes from very simple, prompt engineering, crafting a prompt to try to get the model to do what you want just with instructions, all the way through building a model from scratch. And it's a spectrum really looking at accuracy, complexity, compute intensiveness. But we tend to show it in this like very linear way where, start with prompt engineering, then use RAG, then try fine tuning. If that doesn't work, I guess it's time to build a model from scratch. But what I would highlight here is when you talk about this iterative path from basic to advanced, each of these steps builds on the previous one. And so when we talk about start with prompt engineering, it's not just because that's quick and easy. It's also going to point out where you might need retrieval or fine-tuning. So if you use prompt engineering and you find out, hey, I'm building a model for the medical domain, and it doesn't seem to know anything about this. I probably need retrieval. Or I'm working on a model for translation and it's really struggling with the right style and tone for the dialect I want to reflect. Well, that's probably a use case for fine-tuning. So that start with prompt engineering helps you figure out, what is my next step and what's missing. And we often kind of position, RAG or fine-tuning, but often, they go together. And we'll talk a little bit more about that in the next slide. But the one thing I'd like to call out here is building a new foundation model from scratch, continuous pre-training, mid-training. These techniques are super advanced, and often you can get what you're looking for by taking an off-the-shelf model, whether it's, a Llama model or an OpenAI model or, Claude, pick your poison, and using techniques like RAG or fine-tuning for customization.
Yeah, when I look at this graph, I mean, I think that linear progression is apt, and it's what's so exciting about this new era that we live in. Right? If we have an idea, we can very quickly prototype something with just a little bit of prompt engineering, and then when we understand, okay, actually, it's not performing here, or there's some issues there, we can slightly up the complexity and create a RAG pipeline and get better context. And then it's often, if we're still struggling with performance, or if the economics of that approach don't make sense, say, okay, I've got it working really well, but I'm using the most expensive model right now, and if I want to deploy this to all of my users, it's not going to be practical. Well, then we can kind of distill the information into a smaller model using the fine-tuning technique. On the pre-training side, that is a serious investment that, to me, I think it's best left to the professionals that are deploying tens of millions of dollars of capital to do this. I would say, like recently with the DeepSeek announcement and kind of the progress they were able to make with more like millions of dollars. I mean, it still doesn't make me say like, okay, yeah, I want to go invest millions of dollars to do this thing that now folks like Meta and DeepSeek are actually providing us for free to build upon. But it is, I think it's really useful to kind of understand this whole spectrum when you're deciding kind of what path to take.
I think you just called out kind of distillation as like the newest hotness. And I think that's really an interesting case of, what can you take from state-of-the-art models and fine tune into these smaller models. And, that is the secret sauce of the like Quen 7B model. And it's definitely a space that we're going to be watching. The one call out I have, it's funny, you said, oh, I like this linear progression. And I sort of hate it because it creates things as like very binary decisions. Like I can do prompt engineering or RAG or fine tuning, but I've worked with a lot of customers and I've seen a lot of use cases and I've built these models myself in previous life, hands on keyboard. It's usually not a binary decision. It's often kind of a choice of both. So if you think of it kind of, all data scientists love a little chart. How much model adaptation do you need? How much do you need to change the behavior of this model, style, tone, format, vocabulary? And how much external knowledge do you need? Things that weren't in the training set. If you're very skewed towards one of those things, I need external knowledge, but I love everything else about this base model. That's RAG. There's definitely use cases like that. If you have a Q&A system where basically you just need the chatbot to retrieve from your knowledge base, this is the correct answer, it needs to be grounded. Perfect, RAG, you're golden. If you're looking at pure model adaptation, where you want to just, model knows everything it needs to know, you just want it to reply in a consistent format, tone, style, that's summarization. So popular example for summarization is, I have chat transcripts, I have transcripts of conversations, I need to summarize those in a specific format. Pure fine tuning, you don't need extra information. But what we see a lot of and what many more customers are going to production with now are these hybrid fine tuning plus RAG use cases, where RAG is still used to pull in that external information to ground in your data. And then fine tuning is used to teach the model what to do with that retrieved information. So you've probably heard of RAFT or retrieval adapted fine tuning. And in this kind of type of fine tuning, you have a set of golden documents and distractor documents. And you train the model to discriminate between these facts are relevant to what I'm doing and these are irrelevant. So that when you deploy the model for, inferencing on a new domain, you're able to retrieve information, use the correct information for your use case, and modify what the model does with that information. So it's really one of those like peanut butter and jelly better together, where likely you're probably going to try RAG on its own and say, this is how far I got. You're going to try fine tuning on its own. You're going to say, these are the shortcomings. And then lots of folks find best results by putting those together.
I like this slide. And agree that there are issues with the linear analogy.
So then just to kind of get us into, we've talked about like, what is fine tuning, RAG fine tuning, what is it going to do for you, right? Why should you bother to fine tune other than, feeling really cool? And we actually see a pretty consistent set of benefits for different use cases. So a lot of folks come to fine tuning looking for enhanced accuracy and performance. And so this is where these classic fine tuning use cases of, I need to adapt my model to a new domain. I want to teach my model all about healthcare. I want to teach my model all about telco. Also in this bucket is this kind of task-specific optimization. So that goes back to the example on the previous slide where, I'm going to create, a summarization model. I'm going to create a model that does translation in this local dialect. This improved performance and accuracy bucket is really popular. I think it's a lot of what people think about when they think about fine tuning. The one like little flag I'd put on this is domain adaptation teaching models new tasks requires a fair bit of data to get right. And I'm sure this is something that our friends at Weights and Biases have lots of experience with. And I'd say these other three buckets, cost efficiency, latency, risk mitigation, are actually where folks see success quickly, and it's much easier to kind of measure success. So we talked about distillation before. Often folks will be fine-tuning a smaller model to replace a larger model. So maybe I have GPT-4o in production, serving customer traffic. I'm happy with it, but gosh, it is expensive and kind of slow. I would rather use 4o mini, improve my bottom line. I might fine-tune 4o mini using the logs from my production 4o deployment and have a smaller, faster, cheaper model. You also sometimes see when you have these very long prompts, lots of few-shot examples, lots of instructions, you have a pretty high per turn cost, right? You can fine-tune your model so that you don't have to have that super long prompt. So the model has had all of those examples trained into it. And this kind of bucket of use makes it really easy to measure the value add of fine-tuning. I went from 700 tokens on average per prompt to 200. Okay, this is what the value add is. I swapped 4o mini for 4o, and this was what the value add is. So we see a lot of adoption in this space. Similar when we talk about, smaller models, shorter prompts, we're also looking at lower latency. And the final kind of bucket for fine-tuning is we talked about risk mitigation. So I mentioned at the beginning, direct preference optimization is an alignment technique that we offer. You can fine-tune a model to change its alignment to align with your organizational kind of preferences. So you can align the model to reflect improved fairness, less bias. The other use case for fine-tuning, going back to Raft, is avoiding hallucinations. Teach the model when to say, I don't know, or when to ignore the extraneous fact. So it's not convincingly making up information. These are really the four buckets that we see a lot of on Azure. Chris, is this kind of what you've seen reflected with your customers as well?
Yeah, 100%. And I think, to your points, getting the enhanced performance and accuracy that's the tough part. And that's why Weights and Biases has built tools to try to help people understand where that's moving. The other thing I think about, especially in this distillation use case, when we're trying to make a smaller model perform better for our specific use case, when you're doing that, you're taking often a model that was trained to be very general and handle any input, and now you're making it solve more of a specific problem. So it's important to, like you said, train the model to say, can't help you here. If someone tries to take it and make it do something that now we've almost asked it to forget how to do some of these other things, and instead just focus on our specific use case. So, yeah.
And then we just talked about super generic, better model, lower costs, but we see a lot of very specific industry use cases. My background is life sciences. Folks in healthcare and life sciences love fine-tuning for knowledge infusion. So you can customize these models with proprietary medical research, electronic health records, clinical guidelines. For diagnostic support, you can fine-tune models for transcription, documentation, physician assistance. And this is, one where if you're a drug company, you have a lot of proprietary information that you want to fine-tune into that model. I talked before about translation and dialects were very popular, especially with the 3.5 Turbo series of models. A lot of us speak with regional accents, dialects, and while these models might be great at general translation, they might not sound super convincing as, using me as an example, someone who grew up in Manhattan and lives in Brooklyn. I choose specific vocabulary, I speak in a specific way. We find many use cases where folks are fine-tuning models to improve the fidelity to their customer base so that they have better customer engagement with context-aware translation. Finance and banking, we always talk about finance and banking just because it's the elephant in the room. For finance, we often see fine-tuning used for risk analysis and decision support, automating kind of financial advisory insights. We talked about Raft earlier, tailoring recommendations based on historical and real-time data. And then the final section that we're going to call out is really legal and compliance. So legal documents follow very specific formats. There is very consistent reasoning. We often see folks fine-tuning models to generate things like contract summaries, legal briefings, compliance documents, and really making sure that you have compliance with all of these generated documents. You're not relying on, I hope the base model does this, but you're fine-tuning in your own organization's knowledge. Do these reflect kind of what you've seen, Chris?
Yeah, absolutely. I mean, I think on the customer service side, especially here at Weights and Biases, we're building our own service, like customer service bot, and have been doing fine-tuning with that use case, where it makes a lot of sense because, A, we have a big history of actual user queries that we can start to fine-tune on essentially replicating our support team's candor and response around issues. And we can also fine-tune on all of our documentation and information about the product so that the model is actually hopefully able to actually satisfy customers' requests. So the other kind of industry use case that I find especially interesting is computer programming. So I don't know if folks have seen like v0.dev from the Vercel team. Very, very cool tool, kind of an agentic tool, which we'll touch on later, that can create UIs and applications. They've done a lot of fine-tuning to ensure the model is producing, high quality code. And if you're trying to make a coding agent and maybe you're using a non-standard technology or something that isn't the most popular thing on the internet, fine-tuning can be really helpful to just understand the semantics of the actual programming language or your existing code base.
Thank you for calling that one out. That was a big miss for forgetting to put on the slide, but definitely adapting to like new programming languages, more obscure languages, kind of internal practices. We see a lot of that with fine-tuning. I'm just going to quickly touch on a couple real-life examples to prove to you we're not just making stuff up about fine-tuning. And then we're going to cut over to the demo. So Microsoft Cloud for Healthcare is one of my very favorite customers. I've worked with them for, I think, about the last 2 years. What they're doing is they fine-tune to improve or alleviate the documentation burden for clinicians. So if you think about when you go to a doctor, often there's a medical scribe typing stuff in, or your doctor is not making eye contact because they are entering information into Epic. They use fine-tuning. Originally, it was just to compare, does this work? But they actually found that fine-tuned models outperformed base models, outperformed their own custom model. And they found that customer feedback on these fine-tuned models was enormously popular. They fine-tuned models basically to teach them how to summarize transcriptions in the right format with the right information so nothing is lost. And they've deployed these in their own products. It's a staple alongside their base models, and it really lets them iterate quickly and generate really high quality results for customers without having to build those models from scratch each and every time. The other use case we like to talk about is Harvey. They make lawyers more efficient with the Azure OpenAI service. We already talked about kind of these legal and compliance use cases. Legal profession has a lot of specific vocabulary, formatting, tone, and style. They fine-tune models for specifically legal professionals, looking at the reasoning and language as applied to legal workflows. And what they were able to do is actually provide significant performance improvements, letting teams complete tasks faster and really unblocking folks to focus on the knowledge work and having the fine-tuned models take care of the kind of rote reasoning and workflows. And then just to talk about, what we've talked about fine-tuning, what do we actually offer in Azure? I've talked about the different techniques. We support many of the Azure OpenAI models, 3.5 Turbo, 4, 4.0, 4.0 Mini. Keep an eye out for the O series models with fine-tuning. We offer regional and global deployments, and this is all GA in our UI, which is Azure AI Foundry. And then I'm going to stop talking to give Chris a little bit of time to talk about what is offered with weights and biases.
Cool. Yeah, I'll be quick because I think the demo is going to tell a better story here. But as we talked about, there's that training loop of needing to find a data set and then actually fine tune and evaluate. The weights and biases platform really provides a number of tools to help you with that process. So number one, we need governance. We need a central place where we have the knowledge of what models have been fine-tuned, what data sets are there to fine-tune on, and how do we share them within our organization. And then a number of features that Anish is going to show around actually evaluating and running experiments with the platform. And we can move to the next slide. Cool. So, I mean, these are generally the barriers that customers are seeing and that weights and biases really tries to break. So when we first started the company, we were seeing people kind of just manually keep track of all of their experiments, which is a recipe for disaster. So we provide really a single source of truth for all of the kind of fine-tuning runs that you've done. And with the kind of ever-growing amount of data that is potentially required to fine-tune these things, we can provide a central registry to keep track of all of those data sets and how they evolve over time. And now as regulations are actually coming into the picture, being able to have this lineage, this actual system of record of what data set was used and how the model was produced is becoming more and more critical. So next slide. Weights and Biases is already partnered with Azure AI, and we're available directly within the Azure console. So any fine-tuning runs that you initiate through Azure will actually show up in a Weights and Biases account if you've enabled the integration. And this way you can have that single source of truth across all of your modeling efforts.
And here's just a sneak peek at what that looks like if you haven't used Foundry before. There's a great UI for fine-tuning. When you set up a fine-tuning job, there's just a little button for adding your weights and biases key. When you run that training job, we will write all those metrics to your weights and biases project. And there you can track all of your different experiments, evaluate your models, monitor, and iterate on their performance while kind of running the training in AI Foundry and doing all of your experiment tracking in weights and biases. So kind of best of both worlds.
Cool. Yeah. Let's see it.
Hey, everyone. I'm excited to show you an example right now of how weights and biases and the Azure AI Foundry work together to create these really powerful workflows that we just heard about right now. So let's go through them. So if for any mention of how to set up, you can go to the weights and biases documentation or also go to the Microsoft documentation, and you'll see they have nice sections to set up all the gnarly bits behind the scenes of actually setting up the keys and all of the proper resources so things stay nice and secure in your own tenanted version of Azure. But let's go to the UI. So today, let's build and fine-tune a chat support bot. So I'm going to start here in the chat playground of the Azure AI Foundry. And you can see I already created this mini deployment of a base GPT-4o mini model, really easily done from the UI over here. And in this situation, what I'm going to do is I'm going to actually give some context to this base model. So I'm going to say, You are a customer support agent helping users with their inquiries. Be professional, clear, and helpful. I'm also going to ask this question of, I can't order a specific order number, something we directly took from users who are using our customer support agent in this theoretical use case. And so we can see here is that if you go and you can see this response from 4o Mini, and seemingly it looks good, actually. The tone is quite nice and it has some steps that you can take. However, if we actually dig deeper into the response from here, this actually may not make sense for our specific business and the way that we actually want to portray this information to the users of our business. So for instance, this is a bit long. And this actually may have a call out to information such as go through our website or app, make sure you log into an account, and navigate to order details page. Things that may not exist for what our actual business is, because we actually don't know what customer support agent we're working for. It could be something that does not work necessarily in a web or app field. Maybe these are things that you can only contact support through. And so because that's when you can start to see the immediate need for something like fine-tuning, where we have specific needs of our own business that we want reflected in our customer support agent. So what we could do also is do a bunch of prompt engineering, add in dynamic platforms so we can effectively use something like RAG and ensure that we have like few shot examples in the prompt and whatnot based on what the incoming user inquiry is. So adding layers of complexity on top of our LLM application, which causes our usage of tokens and latency to also increase. So not an ideal solution, as I'm kind of alluding to, due to what I mentioned explodes from adding in all these components to make something as simple as I want my app to sound the way I do and understand the business use case behind the scenes. So what we're going to do is actually fine-tune our model. So this is a cool collection of data synthetically generated from this cool little company called BitText, which talks about how they've seen a lot of success from using the synthetic data to provide a style and format to a vertical assistant. So in this case, customer support and customer service. And then how you can also continuously fine tune on top of this for your specific business. We're going to do multiple layers of fine tuning. For now, we're just going to do this one layer where we're saying we want to make our customer support bot really good for customer service in the way that we want it, which is reflected in this data set that we see here. And that's kind of mentioned in this graphic that we can also see mentioned here. So naturally, what we'll want to do is actually make sure we grab the data that makes the most sense for our specific business that we have in mind. So make sure our customer service agent reflects the tone, style, and information that makes sense. And so in this case, what we'd usually do is something like human annotation. Sorry, inside. Human annotation. We have a human labeler come in and actually label the data set given their own instruction set. But what we can also do is use something called LLM annotation to do something similar. So give instructions to an LLM to actually go and consolidate the large swatches of data available to us. And so naturally doing some of this user mining on our behalf. And so let's do that right now. So this is the Weave interface on top of the Weights and Biases platform. So LM Ops tooling that we'll use side by side with our traditional models tooling also. So this is what we'll use to actually go ahead and define some clusters of users that represent how we want to portray information to each of these personas. So we want our customer service bot to be good with professional users who speak a certain way, so they're polite and use more basic language, casual users, direct users, and etc. So we took some time to user mine over clusters of our data, understand what types of users ask questions to us, so that we can actually grab examples for each of those users and use that as our fine-tuning data. So in code, it can get a bit gnarly. So I'm going to hand wave over some of this as this will be available to you after this talk. But in essence, what we're doing is actually just grabbing examples that match each of the user profiles that we found from our data set and making sure that's reflected in our data. So a nice heterogeneous data set available so our model actually hits every single persona that matters to us. And so because we're using an LM annotation kind of workflow, we want to make sure that we're actually annotating properly. So what we'll do is a way to actually score each of these profiles below, as you can see here, and just ensure that we're grabbing all the available rows. So eventually we get to something that looks like this: a system user assistant style of data set that we can easily retrieve from our centralized system of record and then use that to fine tune our model. So in this case, we grabbed a bunch of different data that reflects the questions that come in from our most frequent user types, and then responses that make the most sense given the tone, style, and information that we want from our specific business. So that looks kind of like this JSON-L format, aka for any of those working on the API side of OpenAI, for instance, or Azure OpenAI, you'll see that it just looks very similar to this. A nice little JSON dictionary where it says messages and a bunch of different roles, as we saw over here. So with that in mind, we can go back to our UI within the Azure AI Foundry, ensure that we set up the weights and biases integration properly, as you can see here, and then actually fine-tune our model. So in this case, I'm going to run a fun little experiment. I'm going to take the 3.45 turbo model, which has now since been deprecated, and actually go and fine-tune this specific model and see, can we make it speak the way that we want it to and still maintain or improve the quality over smarter models. So you can see here that we can log this fine-tuning job to weights and biases. We'll log it to the this specific project name here, and we'll give it a name such as 35 live. And from here, what we can do is actually upload files directly from our computer in that JSON-L format I showed, or use files we already added into our resource here. So I'm going to add the customer support train over here. We also have this validation data set, which has a similar format in JSON-L. We may want to adjust some parameters. In this case, all I'm going to do is just choose a random seed. And I'm going to submit this. And so you'll see now we have our newest model queued and available while with metrics that are going to be streaming to the weights and biases platform. Instead of waiting the time to actually have it train, let's actually go to one example where we already trained this. So one thing I want to point out is you have a couple different areas to look at the available assets generated during training. So you can look at the example of one training experiment's metrics, the printed log information, and any checkpoints that got saved during the fine-tuning process after each epoch, I believe, in this situation. And what's cool here is that we also have this availability to continuously fine-tune once we get more data and more personas that we want to make sure that our model is good at responding to. So what I can do actually also here is see that it links to this URL that will, links to this URL, which will take us to that project we want to see. So we can see here is actually the information that matters to our model training. So the training loss and accuracies, and then the validation losses and accuracies. It's a bit hard to see due to some of the spikes in the data itself, but we want to actually understand, is it still having the patterns we want to see from properly fine-tuned models? So we have some configurations that we can adjust here. So for instance, what I can do is add more line plots or affect the layout directly, or I can actually go in and do something like add smoothing and see whether or not someone had a really strong smoothing here, for instance, and see whether or not the generalized shape of the training is reflected. So we want to curve downwards and to the right. And we can see that we are getting that type of pattern from our data. So at the very least, our model is training effectively, where the accuracy is generally increasing and the loss is generally decreasing. So the real power of having something like this within weights and biases, however, is when I actually run a bunch of fine-tuning jobs. So you can see here, we have a couple 3.5 fine-tunes and a 4.0 fine-tune, all within one screen here, all of which will update live as we see that new experiment come in that we just queued up. And also all these different changes, so such as the smoothing as we see here, will also affect all the different experiments available here. So I'll zoom in a bit. And you know what, maybe I'll just full screen this specific plot. And so we can see all the patterns from each of our trainings is working properly. So we can say generally our data set is something we can probably improve always, but the pattern of training is showing that it's not any giant problems in the data set itself, even though there may be some instability caused from that training. And we actually start to turn on or off some of the models. So for instance, I can see this green one is looking really good, and the next good one is blue. So I'll actually turn off the other two models because I can see I'm probably not going to use them in my production environment, and compare between each of these. Oh, sorry, I meant to say the green and the blue, and see which one I might want to actually either fine-tune more on top of or actually choose to use in production. So I'll jump into this model, go to the overview, and you can see that the Azure fine-tuning job is available here, and actually the link itself. And also any configurations that I set. And all of this is also, what's really nice is I can export any of this data using the API side too. So if I want to do more further analysis on any of the summary metrics that we see here. But enough about the weights and biases UI. Let's actually go and deploy this model and use it. So we can go to here is we can see down in the shared resources section that there's a deployments tab over here. If I click this deployments tab, it'll take you to this page. And you can see that 4.0 mini model that I deployed earlier from the base models, and also one of the fine-tuned models I also chose to deploy. I can also easily just decide to choose any fine-tuned model from here, available from my fine-tune section from the models that did complete training. So what's nice is I can then go back to my chat, change the model instructions to match what was in my training data set, give that same question I asked earlier from 4.0 mini. Of course, something will break in live. Let's see if I just reload this. Clear the chat. There we go. You can see that this is a much shorter response. And what we want our ideal response to say is to have them provide details directly in the chat. So instead of having instructions for 4.0 mini, which said, go to the website, find the order details, and adjust it there, instead, we're just directly saying, hey, this is really important to us that you reached out. Can you give us more details? And so qualitatively, I can say I'm happier with this response, especially the conciseness of the response, alongside asking directly for details within this chat instance, which is what I would want for my business. But this is a qualitative side of things. Let's actually go and quantitatively analyze whether the 4.0 mini model from the base side is worse or better than the fine-tuned model. In this case, I'll give a hint. The fine-tuned model will show us a lot more success. So there's a few ways to do this. One is you can use some built-in scorers from off-the-shelf providers. Weights and Biases offers a few here. So in this case, you may want to check whether or not the text is fluent and easy to understand. And we have some details about how you define that information here. We also might want to do something like use standard similarity type of measures. So because there's a data set where we know the ground truth, we can compare, does the output of our model match any ground truth from our test data set? We also do things such as BERT score, where we actually use a separate embedding style model and compare semantically, does the ideal response match the LM generation? Or we can use something like LLM as a judge, where we use a separate LLM to score the output of the LLM itself against the ideal response too. And so what we're going to do is actually do all of them. So in code, what we can simply do is, after adding something as simple as @weave op, and adding in all of these different packages. So over here, the text similarity by n-grams, the semantic similarity, the fluency score, and an LLM judge, which has a rubric where we would actually pretend to be almost like a human annotator. We'll run them together to our model, where we'll say, hey, compare our fine-tuned model against our 4.0 mini model. This is a bit of code, which we'll share later. But from the UI, all of which is centralized in that one project, which is all under this specific name here, we'll take our test data set and run evaluation. So we'll see here that our fine-tuned model, we can actually go through each example itself and see the output to see whether or not qualitatively it makes sense given the inputs provided to it. Or what we can do is actually ideally compare the smarter and fine-tuned models, both of which have been scored for fluency, n-gram comparison, semantic similarity, and LLM as a judge, and get this nice view here. And so comparing the fine-tuned model against the 4.0 mini model, so you can see that over here, we can see that even though the 4.0 mini model is a little bit more fluent, we have a very similar quality of score between each of them, but the smarter 4 mini model actually does worse in terms of similarity semantically and both using the words that we prefer from our data set. And we can see it takes about twice as long and uses more tokens than our fine-tuned model. So in this situation, we're getting a higher quality response from our fine-tuned model across multiple measures of similarity to our ideal response, and is doing so faster and cheaper. So we can see here that fine-tuning is more useful and successful here. And so as we run more and more models that we want to compare, we can start to build out these comparisons across the field in something like a leaderboard, where all of the versions of our model fine-tunes can be compared and analyzed in one screen over here. So we can go and consolidate all of our fine-tuning jobs, all of our evaluations, and be able to make these really strict comparisons, ready to understand which model to choose for our actual production use case, using weights and biases and the Foundry working together. And so hopefully you'll find success in your own workflows, finding for customer support, medical, code, law, and etc. with fine-tuning, evaluating, all within the weights and biases platform alongside the Azure AI Foundry platform. Thank you for listening to the demo.
Amazing. Let me quick share our closing slides. Awesome. So I saw in the chat someone already asked about agents, so I was so glad we had this slide in the deck. Just talking about what is an agent. It's an AI designed to perform a task. It can be something simple like generation. You can have retrieval with agentic RAG, or it can be taking actions. When we talk about fine-tuning an agents, there's really two ways they come together. One is you can use a fine-tuned model in your agent workflow. You can have, an orchestrator that is routing requests to different models. Some of those models might be fine-tuned models. Maybe you have a model that's fine-tuned for tool use to be very faithful at calling the right tools. Or maybe you fine-tune, a specific model for a specific task and it's part of your orchestra. The other use case is you can fine-tune a model with conversation threads from your agent. So, threads are just another way of tracking, interactions, input, action, response. And those threads can be the basis for fine-tuning your model. Chris, do you have anything you want to talk about on this space?
I could talk for hours on this space, but given we're running close on time, I say we open it up for questions or address any of the remaining ones.
Let me just pull the last slide and we can open up the questions. So if we go from the top, I see we already covered agents. Or Corin asked about, can we talk about the size of the training sample that we should use when trying to fine-tune a pre-trained LLM? I get this question every time we talk about fine-tuning, so it's one of my favorites, and I bet we all have somewhat different opinions. Anish, do you want to talk about, you just did a demo, how big was that data set and how hard was it to pull together?
Yeah, so I would say the data set, surprisingly, you don't need too many examples to actually fine-tune on top of a pre-trained model. And it depends on what type of fine-tuning exists, because there's a lot of different techniques that exist, such as low-rank adaptation versus actually fine-tuning a large-scale model, which both require different scores of data. But in this case, I would say ballpark, I've seen success with around almost 100 examples. It's pretty sufficient. But I think it also depends on how much behavior you want to grab from your data and how many different personas you're actually shoving into that data set. So I think that's why it matters to actually make sure that you create a proper heterogeneous data set that's reflective of the community of data you need yourself.
I always think of it as generally bigger is better, but not just bigger, right? It has to be a distributed, well represented data set. And the thing you really want to be looking out for when fine tuning is to overfit. Like if you're really just making the model like only target these like 100 examples, then it's likely going to do poorly on, you know, some examples that are close to those 100, but outside of the distribution a little bit. You know.
And I think one important call out is, you know, the amount of data is going to really depend on the complexity of the task, right? So if it's a pretty simple task, let's say format in a specific way, you can get away with a much smaller data set where really you are trying to overfit versus like, I want to fine tune a model for a totally new domain that has never been seen before. Well, that's where you're going to be in the tens of thousands, hundreds of thousands of examples to try to move the needle. So like when we're talking about these task specific use cases, hundreds are probably sufficient. But when we go all the way to domain adaptation, you know, it gets more. Maybe next question is how many layers of the model are opened up for fine tuning during the training process? I can say for Azure OpenAI fine tuning, we offer low ranked adaptation. And so what that means is you have the pre-trained weights, which are frozen, and then you have an adapter that you are basically fine tuning. You're figuring out which, you know, what is the lower dimensionality matrix to modify that base model. And so you're really not changing every single weight in the model. Did we offer this because it is much more efficient? So you're only updating, you know, 1.5%, 2% of the parameters. Training is faster. Deployment is a much smaller footprint. It's cheaper. It lets everyone have their own custom, you know, GPT-4o on a pretty small pool of GPUs. So that's kind of our self-service offering. But there's other techniques, you know, there is full fine tuning where you can adjust all of the weights. That is available. You know, you can use Hugging Face repos for that. It's available on Azure ML. It really just depends on which techniques you're choosing.
Yeah, Laura's cool. I mean, especially if you wanted to have kind of multiple specialists or, you know, the things that Apple Intelligence is doing on device, it's a cool use case for that.
Let me check if we have any other questions that we didn't get to. I don't think so. But we're also, I think, exactly, we're 23 seconds over. So good job, us, for staying on time. And thank you, audience, for the right number of questions to keep us on track. This was really fun. I enjoyed being here with you. I don't know if you all have some closing remarks.
No, I echo that. This was really fun. And I hope some folks start their fine-tuning journey. And yeah, all the information is here on the slide. So we'd love to help you in that journey.